Hey, welcome back to the Computer Hardware and OS Essentials lecture series. I created these custom lectures based on A+ certification program, but with few enhancements to improve your IT technical skills and knowledge. So if you haven't seen my previous videos, I'll post a link in the description for those playlists so that you can go ahead and watch them. This would be our 11th lecture in which I will cover network infrastructure. And this is still a part of the network systems lecture that I did previously in lesson 10, but this will give you more enhanced understanding of some other components associated with network infrastructure. The primary objectives of this lecture is to learn about layers of network communication. So I will introduce you to TCP IP model, OSI model, and some delivery methods associated with that. Our primary focus going to be the TCP IP model because the way that the Windows is set up. However, I will do a separate lecture on OSI model so that you can learn about that later. We will learn about network topologies, some basic overview of that. We will go a little bit in depth into IPv4 and IPv6. We will learn about network media and connectors. So we have previously covered some basic overview of that on my previous lectures in this series. But we will go a little bit more detail into copper media, optical fiber, Powerline Ethernet and wireless. And we will cover a little bit about basic tools and some basic troubleshooting. Protocols and communication rules. Individuals must use established rules or agreements to govern the conversation. Same principles apply to computers and networking devices. So what that means is basically if you and I were to speak, we have to decide what language we're going to speak. If you speak in French and I speak in English, and if I don't understand French, that means the communication will break down. So there has to be some kind of a governed establishment or convention between you and me so that we have a common language to communicate. So individuals as humans, you and I have to have a rules of establishments as where we communicate in a certain medium and certain language. So just like that, the same principles has to apply to computers and networking devices. It has those different devices, they have to have a specific standard of rules of communication. Otherwise, they won't be able to communicate, right? So the network protocols define those common sets of rules. So different sets of protocols will define how these devices communicate. So you could look at network protocols as common languages, a network protocol as a common language where each device can communicate with each other. So those can be implemented on software, hardware, or both, and each protocol have one or more of their own functions, formats, and rules. An examples of some common types of protocols that you may have heard in the field and daily life would be the HTTP or HTTPS protocol for web surfing. So if you go to a website, for example, Sanuja.com is on HTTPS:// right? So that because of HTTPS is the 443 port specialized protocol for secure web communication. And the Sanuja.com you access to https://sanuja.com because that's the protocol in use. So that's an example of a very common network protocol that being used for web surfing. So if you access my website, that's how you access it. The other common protocols include the TCP, IP, FTP, SSH is another common network protocol, so etc. etc. Devices must use agreed upon protocols to communicate. So all devices between you and the Sanuja.com website have agreed that the delivery method for Sanuja.com web page going to be HTTPS. So if that agreement is not there, you won't be able to view that page because the communication will break down. Networks require the use of multiple protocols. So whenever you access a network, it probably not just going to use just that HTTPS. It's going to use TCP IP, HTTPS, and many other protocols to make that connection work. For example, your Windows computer is connected to a network if it has internet connection, most likely using the TCP IP protocol. But when you access the Sanuja.com using that TCP IP connection, it will be using the HTTPS protocol to deliver that web page through your TCP IP connection. So therefore, networks require use of multiple protocols to communicate. Network protocol suites are also known as, network protocol suites, also known as models. What they're going to do, those suites are a group of interrelated protocols necessary to perform a communication function and set rules that work together. So these kind of suites will set rules that would work together. There's a spelling mistake right here. Sorry about that. So they should say set rules that work together. So what the network protocol suite's going to do, they're going to work, it has a set of rules that will work with each other. And layers, the lower layers on those kind of suites are concerned with moving data and providing support for the higher layers. And these type of network protocol suites are usually known in the field as models, because there's a like OSI model and TCP IP model. Those are the two commonly used models, widely accepted and adapted across the world. So let's look at those OSI and TCP IP models and see how they are compared to each other. The OSI model, which I have extensively described in my Cisco NetAcad programs, such as the CCNA program that I have already posted a series of lectures onto my YouTube channel, basically have 7 layers. So they are physical, data link, network, transport, session, presentation, and application. The TCP IP model, on the other hand, that uses only less layers, which only have like 4 layers. That includes the network access, internet, transport, and application layers. However, in TCP IP model, the network access layer encompasses the data link and physical layer of the OSI model, and the application layer of the TCP IP model encompasses the session, presentation, and application layers of the OSI model. The OSI model divides the network access layer and the application layer of the TCP IP model into multiple layers as a result, and the TCP IP model suite does not specify which protocols to use when transmitting over a physical medium, as it is a combined into one, right? And OSI layers 1 and 2 discuss the necessary procedures to access the media and the physical means to send data over a network. And the network access layer is also known as a link layer. Again, I will go over some of these items on a separate video, like with specifically the OSI model. And I also have covered these type of models already in my Cisco CCNA NetAcad lectures. You should go ahead and watch those on my YouTube channel. So here's an overview of TCP IP model, because that's the focus for our A+ certification program, and that is what the A+ certification program is based on when it's come to the point the suites or models. So let's start with the lowest layer that you should be familiar with. That would be the layer number 1, that is the link layer. Link layer addressing is the MAC address, because MAC address associated with the physical address, also known as the physical address, is associated with the device. So the device to device on a local network managed by firmware on the network interface card, and the layer 1 is also called the network interface layer or network access layer, because this MAC address is attached to that network interface card. These MAC addresses are also known as physical addresses because it is attached to that network interface card, and within that local network they can communicate using those MAC addresses even without using an IP address as a result of that. So the MAC address will be acting like the the address in which then a network within the local area will be using to communicate. The layer 2 is the internet layer, which is using the IP addresses as opposed to MAC addresses. And that would allow host to host on a local network or network to network communication managed by the operating system and networking devices. So in the MAC addresses, in the layer 1, we can only communicate using MAC addresses within the local network. But with IP addresses, you can do host to host communication either within the local network, or you can do network to network, in other words, external communication. So you can have a home network communicating with a corporate network, for example, using the IP address. So IP address can be globally used. The layer 3, which is a transport layer, that uses the port addresses. So port numbers and port numbering. So that allow host to host communication managed by operating system, basically mostly based on the TCP and UDP protocols. However, there are other protocols too, but in 2022 systems, it's either TCP or UDP. And I will describe what are TCP and UDP in a little bit depth in next few slides. The layer 4, which is the application layer, the application layer allow application to application communication that is managed again by the operating systems using protocols specific to applications. Those include the HTTP, Telnet, FTP, SSH, and etc. And this layer of communication happens after the operating systems have made a connection to the transport layer. So each layer actually depends on the layer below. So in here, the application layer can only work if the transport layer communication has been established. So on the right hand side, we have a diagram that exactly explains what I just described on the left hand side. So if you look at from the bottom to the top, because that's how the layers work, it starts with the link layer and it will have the operating systems and that includes the transport, internet and transport, and then you have the application layer at the top. But if you look at from the user's perspective, you have to look sometimes from the top to bottom. So user is at the very top at the application layer, because that's where the user going to interact, right? So for example, your web browser, whether it's a Google Chrome or Firefox, going to be an application, right? So as a user, you would be sitting way up top here, and you will be accessing, let's say, Sanuja.com website. So you're going to say, hey, get me the Sanuja.com website. So this is going to be HTTPS as opposed to HTTP request. So HTTP run on port 80, which is an older protocol. Most websites in modern day don't use that HTTP connection. But if imagine this is HTTPS communication and it requests the web server, hey, I need this web page. So it's saying, hey, I need to access Sanuja.com web page. So as a result, that web server then going to send TCP or UDP port addresses back to the user. So it's going to communicate that information, and it's going to also communicate the IP addresses. And then as a result, on your device, the network interface card going to communicate with the network interface card on the web server. So that's how this final communication going to happen. Please keep in mind, this is a broad, high-level overview of how TCP IP model works. So this is not exactly how the high in-depth analysis of how those communications work. This is a broad overview of that. So please keep that in mind, because for A+ certification, you need to know a little bit more than this, but this is all that we're going to cover in this lecture. Otherwise, this lecture going to be like 10 hours long, right? So that's why. So keep that in mind. However, if you want to learn more, please go and watch my CCNA videos on my YouTube channel. So I have posted CCNA 1, CCNA 2, and CCNA 3 lecture series that covers OSI model especially in depth, and as well as some related concept related to TCP IP model. And I would recommend that you go and watch those videos if you want to get more comprehensive understanding about how these models work. It is important that you understand basic overview of this TCP IP model, but not into the point that at the level of network engineering, but you still have to understand how these models work for your A+ certification program. TCP IP and Windows networking. So regardless of the protocol suite or the model that we use, TCP IP, it doesn't matter whether it's a TCP IP or OSI, the fundamental functions remains the same. So it doesn't matter the Windows is actually using the TCP IP type of model to connect to networks. Regardless of whether you're using TCP IP or OSI model, the fundamental functions of networking remains the same. Microsoft Windows communication devices are based on TCP IP model. Important characteristic of the characteristic that is kind of model dependent includes that it does have some impact on the model. So like even though it doesn't matter regardless of whether you're TCP IP model or OSI model, the fundamental concepts are the same, but there are some important characteristics that are unique to TCP IP model as well. Those include devices on the same LAN can use the MAC addresses to communicate, but computers on different LANs use IP addresses to communicate over the internet. So as I briefly mentioned on my previous slide, so the devices on the same LAN, so if you are connected to your home network, you can communicate between two network connected devices on your home network just using MAC addresses. But if you want to communicate to your friend's house or you want to communicate to the internet, then you have to use IP addresses. So that's a characteristic of this model. This applies to also the OSI model as well, but it is also unique to the TCP IP model. Each server running on a computer is addressed by unique port number. So that means each server service or services that are running on your device has to be identified the port number. Like for example, if you were to run a web server from your home, your port number going to be 443 or port 80, either secure port or the other one, right? So that's what I meant by that. A host such as a router can always determine if an IP address is on its network. How does it know that? Because it has something called subnet mask, and using the subnet mask as well as the IP address itself with different octets in there, it can determine whether the IP address is an internal IP address or an external IP address. With respect to IPv4, there is such thing called the NAT, which is basically sitting between your internal network and the external network, which I'm not going to go into depth in A+ certification program. You can learn that in my CCNA program lectures. That will allow us the separation between the internal IP on its own network versus external IPs as well. Each service or server running on a device is addressed by a unique port number as well. For example, port 80, 443, for web port 25, for email, etc, etc. Actually, it is mentioned up here as well. Sorry about that. So it is the same thing repeated twice, but yeah, that's what I meant by that. So that it's for example, port 80 and 443 associated with web and port 25 associated with email. To view IP settings in a Windows device, you can use the ipconfig command in the command prompt window, and it will show you the IPv4 and IPv6 addresses assigned to all network connections. You don't need the elevated administrative privileges on the command prompt to do this. So even on your office computer that you have some administrative lockdown, you may be able to run ipconfig command unless it is specifically blocked by some kind of a group policy. What happens when a computer using IPv6 make a network connection is that the computer creates its IPv6 address by using the FE80::/64 prefix and uses its MAC address to generate an interface ID for the last 64 bits. Then it performs a duplicate address detection process to make sure its IP address is unique on the network. It asks if a DHCP version 6 server is present on the network to provide configuration information, and if a server responds with the IP, DHCP information, the computer uses it instead. This is all high-level overview of how IPv6 works. again, I have in-depth analysis of how exactly IPv6 work and how IPv6 is different from IPv4, which which doesn't do the creation of automatic IP addresses by itself. It's basically obtained from a DHCP server in IPv4 version in my CCNA lectures. This is a high-level overview so that you have a better understanding of how this works, the IP systems work for your A+ certification program. I will discuss a little bit about IPv6 and IPv4 addressing in the next few slides in this lecture as well. But again, I need to highlight this. We are doing high-level overview in these A+ certification program lectures. So here is an example of ipconfig/all command, and it gives me some information from my virtual machine in my lab environment. And in here we see the host name as Win11 Pro X whatever, right? That's the host name I have. And it has also some information about the domain. So in my lab environment, I have sanuja.local. That's how I have set up my lab virtual machines. It is connected to that domain, so it shows that information. But what we are interested in this class is the information below with respect to the Ethernet adapters. So here's one Ethernet adapter, and in here we have the physical address, which is this letter and number stuff, and it is the layer 1 address, because physical address is the MAC address and that is associated with layer 1, and sometimes the MAC address is known as a physical address because it has they are typically associated with the physical device or network connected device such as the network port. Then we see the link local IPv6 address right here, and you can see that the format, the double colon and colon format associated with IP v6 address, the link local. And then right below it we have the IPv6 address, which has that dot instead of the colon, and in here we have 192.168.26.6, and that is what the IPv4 address that obtained by this particular virtual machine. And there are some other information as well, such as the subnet mask right here, which has to do with IPv4, which is 255.255.255.0, and it shows the default gateway associated with this, DHCP server associated with it, and a bunch of other information such as DNS server, etc., etc. Internet protocol addresses. So an IP address or the Internet protocol address has either 32 or 128 bits. This is because the Internet protocol version number 4, also known as IPv4, uses 32-bit addresses to identify a network connection, while the IPv6, which is the Internet protocol version 6, use the 128-bit addresses. So the IPv4 currently, we are in a situation there's a shortage of IPv4 addresses, and therefore we are basically running out of IP addresses at the global scale. There are ways that we try to prevent IPv4 exhaustion, such as creating NAT, which is a network address translation, which again I'm not going to go into depth here. However, it is not a permanent solution. So what we did is that we came up with a new IP version called the IPv6 that use 128-bit IP addresses that will give us way more than we needed for current usage. So the Internet Assigned Numbers Authority, also known as IANA or IANA, is responsible for keeping track of those assigned IP addresses for both IPv4 and IPv6. So let's look at IPv4 addresses in little bit depth. So an IPv4 address is a 32-bit long address organized into 4 groups, and each of those groups is 8 bits long. Hence the term we use the octet. Oct mean 8, octet. So each of these bits are usually refer to as octet. So 1 octet, 2nd octet, 3rd octet, 4th octet. That because of each of these contain 8 bits. And in decimal format, it is represented with dots separating each octet. So for example, 72.56.105.12, right? And then the largest possible 8-bit number in this format is 255 in decimal format. The reason for that is, if you look at this 8-bit, so we have 1, 2, 3, 4, 5, 6, 7, 8. In digital, format, like, or the bit format, what we have here is, like, you can convert all these zeros into 1, and when you do that, when you have those 8 bits, all of those 8 bits converted into 1, it will result in 255. That's why 255 is the maximum you can get out of one of those 8-bit locations. The largest possible decimal IP address, therefore, going to be 255.255.255.255, which in binary, which is in bit format, going to be all ones in here. So remember that. The reason why it is the maximum 255, because we only have 8 bits, and in binary we can convert all of them into ones, and that is a maximum value. That will be the 255. Octet, as I mentioned previously briefly, is that each of these 4 decimal numbers are separated by a period, and each of them are known as an octet. So this is an octet, this is an octet, this is octet, this is octet. That because of those are 8-bit numbers, and each of these things known as octet, and they can go from 0 all the way to 255, right? Because that's the maximum. 0 going to be 0, 0, 0, 0, 0, 0, 0. So or 8 zeros will give us a 0, and 8 ones will give us a 255, and the combinations of binary numbers in between give us the other numbers from 0 all the way to 255. Some IP addresses are reserved and should not be assigned to a device on a network. And again, I'm not going to go into depth of those things for this particular lecture, but you should know that is a thing. So some of the reserve IP addresses includes the loopback IP addresses. That includes the 172.0.0.1. That's a reserve loopback IP address that indicates your own computer and is called the loopback address. So why do we have this? Because this is a good way to check your TCP IP stack on your own computer. So if you have a network connection issues, you can actually ping the loopback address in order for you to test the connectivity. So here's a good troubleshooting method if you are experiencing connectivity issues. The first thing I would do, actually try to ping an outside device, obviously, or a device within your network. But if that fails, then I would ping 172.0.0.1 to see if my TCP IP stack is working within my own computer. So that's what the loopback address is doing. It's actually testing your own computer's or device TCP IP stack. The 0.0.0.0 is also a reserve IP address, which is currently unassigned IP address by the INA, so that it has been reserved. And the other one is the 255.255.255.255, which is also known as COD 255, which is used for broadcast messages by the TCP IP background processes to communicate with all devices on a network at the same time or without needing specific recipient information, such as when a device uses DHCP to send out a request to any host that might be running a DHCP server to get an IP address. So if you have a device that just connected to your network and required a DHCP IP address from a DHCP server, it can use the broadcast address COD 255 to send that broadcast message. So therefore, this is also a reserve IP address. Broadcasting can cause a lot of network chatter, or in other words, congestion. To reduce those chatters, we create subnets that are created to subdivide a network into smaller networks so that the fewer devices receive and respond broadcast messages. Again, I'm not going to go into depth of how subnetting is done on a IPv4. What you need to know is that subnet basically divide the broadcast domain into smaller pieces. So IP addresses identify the network and host. So especially when you're looking at the IPv4 addresses, it can easily identify your network and the host. So the first part of the IP address identify the network, and the last part identify the hosts. Like for example, the range of IP addresses assigned to a local network in this example would be like 192.168.80.1 all the way to 192.168.80.100. So that's the range. So why that is the range? Because the first 3 octet, which is the 192.168.80, is the network. And the last octet, which goes from .1 to .100, identify each host. So that's how you read an IPv4 address. So the network portion goes from 192.168.80, and then the host portion is the last octet that could be, in this example, either .1 all the way to .100. So it could be .50, .44, .80, .77, .35, etc., etc. .1, everything is part of that network. Subnet mask. So how that works is the subnet mask identify which part of the IP address is the network ID and which part is the host ID. The subnet mask help a device know if an IP address is a part of its network or belong to another network. And I will describe how subnet masks work in little bit in detail on my next slide. So subnet mask in IPv4, how that works is that it has 32 bits and is a string of ones followed by a string of zeros. Like for example, if you have a IP address of a computer that has 201.18.20.160 with the subnet mask of all of these octet are 1 in here, this octet is also all 1 and everything else is 0. This particular subnet mask tell the Windows that the first 16 bits of which is the first 2 octets, this one and this one, 8. The first octet it has 8, second octet have 8, that's how we call them octet. 8 plus 8 or 8 times 2 is 16, therefore 16 bits of the IP address is the network ID. So the subnet mask tells the Windows the first 16 bits of the IP address is the network ID. And the network ID in this case is going to be 201.18.0 becomes .0.0, and the host is going to be the 20.160. Why? Because this the way that the subnet masks work, because these are all ones, so they're going to count as a part of the network. So this octet is associated that octet, this octet is associated second octet, and the third octet associated third, and the fourth octet associated fourth, right? So because the first 2 octets are all ones, we know the network ID is 201.18.0.0 because we only count these first 2 octets and the rest gonna become zeros when you want to know the network, network address, right? Network ID. And then the host ID become the last 2 octets, which is going to be 20 and 160. And why that is? Because these are zeros now in here. So the last 2 octets just going to be the host IDs. Sometimes an IP address and subnet masks are written using the shorthand notation. Might be written, for example, 201.16.20.160/16. /16 means basically first 16 bits identify the network, known as the CIDR notation. So that's all you need to know about like how you can read those subnet masks for A+ certification program. So let's look at public, private, and automatic private addresses. So automatic private IP addresses, also known as a PIPA. So public IP addresses are available to the internet, hence why we call it public. When it's come to the point IPv4, you can have a public IP addresses as well as a private IP addresses separated by something called a NAT, or network address translation. Basically your router act as a NAT, basically a network, the separation between your public facing IP addresses and private facing IP addresses. So if you go to a website, if you go to Google and if you type what is my IP, what you're going to get from that query is the IP address of your public facing IP address. So that is the IP address, public IP address that your ISP have assigned to your device, your network. However, your private IP address, if you run ipconfig/all, for example, or ipconfig on your Windows machine, the address that is, for example, 192.168.10.5, for example, is that your private IP address. So that because of you are behind a NAT, and NAT is basically taking requests from your private IP address and translating into your public IP address to communicate with the outside world. So most homes, for example, only have one public facing IP address, but multiple private IP addresses, hence allowing all of your internal devices to communicate to outside the LAN, right? So I'm not going to go into exact detail on how NAT or network address translation works. Just know that that is the primary purpose of a NAT in IPv4 situation. It basically act like a divider between the public facing and the private facing devices or IP addresses. The private IP addresses are used therefore on a company's private network or your home's private network. The IEEE recommends using the following IP addresses for private networks. That includes 10.0.0.0 through 10.255.255.255, or 172.16.0.0 through all the way to 172.31.255.255, or 192.168.0.0 through 192.168.255.255. And Apple routers and switches are usually associated with this part, and other routers and switches typically associated with this part, and some of them might use on this range as well. So you can use any of these ranges. It doesn't really matter. You can reconfigure an Apple router or a switch into working the 192.168.8.0 through 192.168.255.255. But right out of the box, most of the Apple devices that I have installed in the field and at home are typically associated with this range, while the D-Link and the Cisco and etc. typically associated with this range. But you can use any of these ranges, and these are only recommendation by IEEE and not typically enforced by anybody, but this is what we are using in the industry standards. Computers unable to list an IP address from a DSCP server will generate its own automatic private IP address, also known as APIPA, in the address range of 192.254.x and y. So basically X and Y could be any number that associated with that octet, within that octet range, which is maximum of, remember, 255. So this could be, so 169.254.0 all the way to 255.0 all the way to 255 can be the X and Y. And this APIPA is associated with IPv4 addressing scheme, not IPv6, which I will describe next. And again, this only happens when a device connects to a network and it is looking for a DSCP IP address, but the DSCP server is too late to respond to that request. So there is a significant bog down or congestion in the network, so the DSCP server cannot reach the device in time, or the DSCP servers are unavailable. As a result, the APIPA will be giving a unique IP address associated with 192.254 range. And as a network technician or network engineer, you will be quickly identify those things as problematic issues that you need to solve. So what APIPA is doing is it is assigning an auto-created IP address, but it won't be able to communicate to outside world and have some network connectivity issue as a result. So whenever you see the 169.254 addresses, you know that is an APIPA address. And it is very specific to IPv4 addressing schemes. NAT, which I have mentioned to you multiple times and very important in IPv4 addressing, is stand for network address translation, and it is a technique designed to conserve the number of public IP addresses needed by a network. So remember, I mentioned within your house, you can have many devices connected through 192.168, for example, IP addressing scheme, but you only need maybe one IP address. Most homes only have one public facing IP address for the outside world. And how that works is that works with the NAT. So what happened is a router substitute the public IP address of the router for the private IP address of a computer that needs to communicate to the internet. So if you have, let's say, your family, let's say your brother, your mom, or your dad is connecting to the internet, and you are also connected to the internet, they're all going to use the same public facing IP address, but you're going to have multiple different IP addresses within your local area network, probably within the range, any of these ranges described here up here, to access that outside world. For example, let's say your mom has 172.16.0.10 and you have 172.16.0.20, and you both can communicate to outside world, but the outside world not going to see the 172.16.0.10 or 20. Outside world going to see something like whatever the unique IP address, let's say 72.55.16.12, which is the public facing address that have been assigned by your ISP. And why we do this? Because we are running out of IPv4 addresses. So everybody in the entire world can have a unique IPv4 address for public communication, because we are exhausted out those IP addresses. As a result, we are using this NAT translation as a temporary measure at this time to conserve IPv4 addresses. So this way we have a limited number of IPv4 globally routable addresses, but behind a NAT within your local area network or within your LAN, you can have many different devices connecting to your public facing IP address using multiple different internal IP addresses without creating IPv4 exhaustion in the public domain. So in the public routable IP addresses are not directly associated with your computer. So in the IPv4 configuration, so the computer has to go through the NAT translation in order to communicate to the outside world. IPv6 addresses. So an IPv6 address has 128 bits written as 8 blocks of hexadecimal numbers separated by colons. So actually they are not semicolon, they are colons, sorry about that. So we have 2001 colon, and then you have something, here, and then the colon and colon and colon, and those colons gonna separate your IPv6 address. Each block is 16 bits. Remember, previously it's only like 8 bits, but this time we have 16 bits. So the leading zeros in a 4-character hex blocks can be eliminated because the IP addresses in here, for example, can be written as this way. Like instead of having this 0 at the front, you can just enter B80 instead of having 0B80. Instead of saying 00D3, we can enter D3 because those zeros have no value change to that that 128-bit value. 0B80 in 128-bit format is same as B80. Again, I'm not going to go into detail about how the math works here, but you should know this as a broad overview for your A+ certification exams. If block contains all zeros, they can be written as double colons. So if the IP address above can be written in 2 ways, for example, in this block we have all zeros. These 2 blocks we also have all zeros. So you can either write as 2001 : B80 : 000 : D3 : 9C5 etc, or you can write 2001 : 000 B80 : and then so on and so forth. So if a block contains all zeros, you can use those double colons to reduce the size of your the IPv6 address writing, but it doesn't actually change the actual size of the IP address. It just changes the way how you represent it. However, if you're going to use this type of collapsing method of writing it down, only one set of double colon is used. So the preferred method is the second one. So if you have multiple blocks here with zeros, you can use this double colon collapsing on here and here. You only can use once. So the preferred method is not to use the very first one, but the very last ones that have double collapsing. So that's the preferred method. So keep that in mind. You can collapse the whole IPv6 address everywhere you see zeros. You can only do once, because otherwise the address is going to be incomprehensible, right? That's why. Again, I'm not going to go into the depth of mathematics in here, how IPv6 or IPv4 addresses work, because it is not required for your A+ certification program. You need to understand the broad overview of how these things work. Terms used in the IPv6 standards include something called a link, which is a local area network LAN or wide area network WAN bounded by routers. Those are called a link in the IPv4 systems. Node, which is another term you may hear in the IPv6 addressing schemes, that is any device that connects to a network. A connection can be logical or physical. So it could be a logical connection, such as a virtual machine gonna have a logical connection with the IPv6 addressing scheme. A physical connection, which is the actual network interface card obtaining an IPv6 address. So those are in IPv6 connections we are called nodes. So anytime there is a IPv6 connection, whether it's a logical such as a virtual machine or physical, a network interface card connection, we call it a node. Interface ID, which is at least 64-bit long or 4 blocks of an IP address. Neighbors, which are 2 or more nodes on the same local network. And those are key terms that you should know that exist in IPv6, but you don't need to understand in depth of how the network engineering side of this works in the A+ certification program. However, for your CCNA certification or CCNP certifications, you do need to know how exactly these things work. And again, I have extensively go through these explanations of these things on my previous lectures associated with CCNA lecture series. And please go ahead and watch those if you would like to learn more about these things. Types of IPv6 addresses include the multicast address, anycast address, and unicast addresses. Again, the only thing you need to learn is that the multicast address packets are delivered to all nodes in a targeted multicast group, while the anycast addresses are used by routers to identify multiple destinations and packets that are delivered to the closest destination, while the unicast addresses are packets that are delivered to a single node on a network. So that's all you need to understand for your exams for A+ certification for now. I will go in a little bit depth later sometime, but if you want to learn about it right now, about how network engineering side of things work, please watch my CCNA and CCNP lectures that I have already posted to my YouTube channel. There are 3 types of unicast addresses. That includes the link local unicast address. Those are the link local or local addresses that can be used for communicating with the nodes in the same link. So most begin with the FE80:/64 and begins with FE80 followed by through zeros to make it 64-bit, because it has to be a 64-bit address. That's why it's /64. Unique local address, also known as ULA, is a private address used by network administrators when subnetting a network. And again, that is more to do with network engineering than A+ certification program. Global unicast address, also known as the global address, can be routed on the internet, and that is the first 48 bits of the global routing prefix assigned by your ISP. But keep in mind, IPv6 does not have NAT translation. You don't have a NAT in IPv6. There is a thing called IPv6 NAT, but it's not necessarily, and we are not going to discuss that today. But keep in mind, more IPv6 addresses are globally routable. It's not privately routable, not a private address, right? It is privately routable too, but it's not a private address. So here are some big overall overview of IPv6 address types. And this is the fundamentals that you need to understand for your A+ certification program, because we are not going into any more depth than this, because you just need to understand how IPv6 works an IPv4 works in order for you to troubleshoot a problem in the field, because that's what the A+ certified technicians do when you have the certifications, right? So keep that in mind. So we have the multicast address, which remember, which is the FF00:/88. I mentioned the multicast address in the past, but this is what it is. So the first 8 bit are always going to be ones. Link local address, which I described briefly on my previous slide, which is start with FE80 and :/64, and the first 64 bits are always going to be like this, and the unique local address is FC00::7, and then the first 7 bits are always going to be like this, and then the global address is going to be 2000::3, and the unassigned addresses includes the 0::0, which are all going to be zeros, and the loopback address, which is an important one too in the IPv6, is going to be 0::1, also known as ::1, because the 0 can be dropped here. So this is very commonly described as ::1, and 127 zeros followed by 1. That's what the loopback address is representing. Again, for your A+ certification program, you are trying to be a network technician. You're not going to be a network engineer, right? That's not the purpose. If you want to be a network engineer, you're going to be studying CCNA 1, CCNA 2, CCNA 3, and CCNP programs. That's where you're going to be becoming a network engineer. Right now, what we are trying to understand is the fundamental concept of IPv4 and IPv6 enough for you to be able to troubleshoot a problem with IPv4 and IPv6 in the field. So this is a broad overview, and that's all you need to learn for your A+ certification program as of now. Okay, keep that in mind. So now we're going to switch gear a little bit. We're going to discuss TCP and UDP delivery. TCP guarantees delivery. So the TCP stands for Transmission Control Protocol, and it is a connection-oriented protocol. So when a TCP message reaches its destination, an acknowledgement is sent back to the source. So if the source does not receive the acknowledgement, it resends the data or passes an error message block to the higher level application protocol. So in other words, TCP guarantees delivery. It is a method to make sure that delivery of message is done between two network connected devices or multiple network connected devices. The UDP, on the other hand, provides fast transmission. So UDP stands for User Diagram Protocol, does not guarantee delivery by first establishing a connection or by checking whether the data is received. UDP is a connectionless protocol. That means it is a best effort protocol. It is doing its best to deliver the data, but there is no guaranteed in connection. There is no guarantee of delivery. And it is used for broadcasting where guaranteed delivery is not as important as fast transmission. So where we need the extremely fast communication, but doesn't necessarily need to be guaranteed delivery. That's where the UDP is used. And also used to monitor network traffic. So the UDP connections are also used to monitor network traffic. An example of a UDP connection would be the YouTube that you're watching right now. So the UDP is used for things like video transmission, the video delivery, the video buffering that is happening right now, maybe on your YouTube video right now, the video that you're watching, my YouTube channel videos, is basically using the UDP. It is using the UDP to communicate that information. What you need to understand for your A+ certification is that there are two types of delivery, that is TCP and UDP. TCP is Transmission Control Protocol, and the UDP is a User Diagram Protocol, and the TCP guaranteed delivery, and it is a connection oriented protocol, the TCP, while the UDP is a connectionless type of protocol, and that is good for fast communication as opposed to guaranteed delivery. And here are some common TCP IP protocols that we use. And they include things like HTTP, which is Hypertext Transfer Protocol. And you should know these common types of protocols for your A+ certification exam. For example, they could ask you what is POP and IMAP, or give an example of give me a reason why we use HTTPS over HTTP. You should know why they are different from each other, but you don't need to know the exact mechanism of how they work, right? So the HTTP, which is Hypertext Transfer Protocol, would be the protocol used for World Wide Web and by web browsers and servers to communicate. So if you go to a website that use port 80, you'll be using HTTP. HTTPS is the secure version of HTTP. So that is stand for HTTP secure, and that encrypts and decrypts data before sent and processed. So the server that you are connecting to access that website have encryption built into it. Like for example, if you go to sanuja.com, that will be using HTTPS port 443, which I will describe in the next few slides later why ports are important to communicate to you. So therefore it is encrypting data between my web server and you, because it is using HTTPS. So these are two same, it does the similar thing in terms, because they are both used for delivering web pages to the end users, but one is secure, one is not, because they are two different protocols. SMTP is a simple mail transfer protocol used to send emails. POP and IMAP used for deliver of email messages. RDP, which is used by Windows Remote Desktop and Remote Assistant utilities to remotely connect and control a computer. Telnet is used to remotely control a computer or a networking device. So it could be a Cisco switch. A router, for example, can be accessed through Telnet as well. RDP and Telnet are considered as unsecure connections or insecure connections, and Telnet is almost now becoming legacy connections as SSH have taken over. SSH, which is the secure shell, which is kind of a replacement for Telnet, used to pass logging information to a remote computer and control that computer or networking device, such as a router or a switch, over a network. And SSH is what we have replaced the Telnet with. So Telnet is being phased out and considered as legacy, and SSH is what we use today in 2022 to connect to networking devices nowadays. FTP again is a file transfer protocol, which is an unsecure version of that, and the transfer files between two computers. And the secure FTP, which is SFTP, uses SSH encryption, and FTPS uses SSL encryption. So if somebody asks you, this is a really good question that could come up on your A+ certification program. What is the differences between SFTP and FTPS? SFTP is SSH encryption, while the FTPS is SSL encryption. So this is more secure, in my opinion, than the SSL encryption, but it is both secure than just using pure FTP. SMB stands for Server Message Block, which is used by Windows to share files and printers. And SMB is often being implemented on file servers within a enterprise or home networks to send access files or printers within the LAN. AFTP, which stands for Apple Filing Protocol, is the file access protocol used by the earlier editions of Mac OS that is currently considered as legacy and no longer in use. LDAP, which stands for Lightweight Directory Access Protocol, is used by clients when an application needs to query a database. LDAP is used by things like Microsoft Windows Server with association with how their Active Directory domain controllers work. So LDAP is still a in use modern day technology in 2022. SNMP stands for Simple Network Management Protocol, which is used to monitor network traffic and monitor certain network KPIs or key performance indicators. So that can be used for monitoring the health of your network and networking devices. That's what the SNMP is typically used for. Those will be gathering network health information, network data. So here are some common TCP IP protocols and port numbers that you should be familiar with. Unfortunately, you may have to memorize this table. So there are hundreds of ports associated with specific protocols, but you only need to know most common handful of ports for your professional certification exams and job interviews. So it's not just for your A+ certification exam and CCNA, CCNP exams, but you may need to know these things for your job interviews. You can go to a job interview and your boss or whoever interviewing may ask you, what is the port number for POP3? Because that's a legitimate question. As a network technician or a A+ certified technician, you should know this. I have an article published on this on my website, sanuja.com. I may leave a link in the description of this video as well, so you can simply click on it. That describe these ports. You should know all of these ports. You should know what the port number associated with FTP and whether it's a TCP connection or UDP connection. Like for example, FTP connections are TCP, which is a connection-oriented connection, and it is guaranteed delivery of data, as opposed to a connection such as SNMP connection, which is going to be UDP connection. That is a connectionless connection, right? It's not connection oriented. Sorry, it is not a connection oriented connection, and it doesn't guarantee data, SNMP, the delivery of data. While connections such as DSCP use both TCP and UDP connection because of the way that the server, which uses port 87, and the client, which is using port 68 works, right? Again, I didn't go into depth of how exactly DSCP works because it is not part of the A+ certification program. If you are interested in that, please go ahead and watch my CCNA, CCNP lecture series that I have already posted to my YouTube channel. But keep in mind, for your A+ certification exam, you need to know these protocols and what general port it is associated with, and what secure port, which is if it is available, if there is a secure port, and what that is associated with, so that you are familiar with these items when you are writing your exams. Like for example, Telnet doesn't even have a secure port, but SNMP does have a secure port and FTP does have a secure port. You need to know this, and you need to know which TCP IP protocols will be used for what application, what protocol associated with. So what TCP IP is doing with respect to what protocol that you're going to be using. So keep that in mind. So unfortunately, this is a table you just have to memorize and know it by heart. Character-based device identification. Character-based names are used to substitute for IP addresses. So they include things like host name, which is the computer name or the name of the computer. You can call it either way. Work group, which is a group of computers on a peer-to-peer network that are sharing resources. So that's the work group is commonly used by your Windows network connected devices, especially in the work environment, enterprise environment, with the ADDS, Active Directory Domain Controllers, which I'm not going to cover in A+ certification program because again, it's not part of your program. The domain name, which identify a network, such as sanuja.local. Remember, I mentioned in my lab environment, I have a bunch of virtual machines connected to sanuja.local domain, and they are part of that one single network. Fully qualified domain name, also known as FQDN, which is also a character-based device identifier that identifies a computer and a network to which it belongs. And it uses name resolution. In other words, like for example, sanuja.com or www.sanuja.com are fully qualified domain names. That particular domain name, sanuja.com, is associated with a computer that is acting like the web server, which is a web server that gonna deliver web pages associated with that sanuja.com. So it uses the name resolution to identify web resources associated with sanuja.com. So that's what the FQDN stand for. FQDN is the domain name of that is globally routable, globally reachable domain name is the fully qualified domain name. So sanuja.com, google.com, cisco.com, anything like that, or youtube.com is a fully qualified domain name. DNS services and protocols manage name resolution. So how the fully qualified domain name going to work? It's going to be using the DNS servers. So DNS servers provide the DNS services and protocols that are going to manage those things. When Windows is trying to resolve a computer name to an IP address, it has to go through the DNS services. So it first looks in the DNS cache. So that means every Windows device on your network will have its own DNS cache from previous DNS resolutions. And if that cache does not have that information, the Windows turns to a DNS server to find the IP address. And this is called the DNS client. So keep that in mind. So the Windows machines, when they are looking for information based on character-based device identification, it has to go through name resolution, and those are called DNS or domain name servers. Local network infrastructure. So we're going to switch gear right now completely to a completely different concept. This is called this is where we're going to cover the local network infrastructure. So LAN infrastructure is composed of networking components within an organization, building or home or a specified geographic area. So if somebody in your A+ certification exam, somebody asks you, what is a LAN? So LAN is basically composed of networking component within an organization, building, home, or a specified geographic area. So your campus network, for example, between different buildings can still consider as a one single LAN. Even though it's technically a WAN, you can still consider as a one single LAN depending on how you configure your network. Handheld mobile devices, laptops, desktop and servers, other network connected devices such as printers, switches and routers, infrastructure devices, in other words, such as the hubs, which are legacy devices, switches, bridges and routers, and network media and connectors are all part of the LAN network infrastructure. So the network media could be fiber optic cables, Cat5, Cat6 cables, those are network media. And, all of those things interconnected with each other within your local area network is part of your local area network infrastructure or LAN infrastructure. So let's look at some network topologies associated with both LAN and sometimes wide area network as well. And those includes things like star and extended star. So those look like these. So you have a central hub or router switch or device that is connecting multiple devices to that. That is a centralized way of doing it. So that is called a star, and the extended star will have multiple of these things interconnected, but those devices still acting like star. Then we have the ring networks. This looks like these. Mesh networks. This looks like this. So the mesh networks are have communication lines connecting to each other, and they are bouncing off each other. So if this connection fails, this one guy still have connection to this guy through the other guys. So that's what they make it a mesh. So it's like a mesh, like a metal mesh, or a metal mesh, one of those things that you put it on your fences, for example. So it's like a mesh. It's connected, interconnected. And then we have the bus connections, which are legacy that no longer in use. We still use star, ring, and hierarchical topologies. Hierarchical topology where you have, which I haven't described here. You have the, networking devices, intermediary devices, but they are connected to each other in this kind of fashion. And the bus topology is basically legacy. Nobody uses bus topology nowadays, but all of these topologies are still in use. Not so much in ring, but still rings are in use in certain networks. So keep that in mind. And again, I will go over some of these networks in next few slides, but not all of them, because just to conserve some time, because as we discuss some network technologies, I will discuss, for example, mesh topology, for example. Okay, keep that in mind. Switches versus hubs. So most wired networks use a star bus topology. So it's not a bus topology, it's a star bus topology. So the nodes connected to one or more centralized hub or switch that look like a star, but then you have a type of bus type of topology combination, right? Hub is a pass-through device that is basically give no regards for data or frame destination. Hub is like a dumb device. It just passes data across everything. It doesn't analyze any packets associated with the frames or packets or etc, right? Any data associated with that packet or frame are not analyzed through hubs at all. So hubs are considered as legacy technology, and it is pretty much not in use in 2022. If you are building a new local area network, you will not use hubs in 2022 because hubs are basically phased out from use. Switches are what now being used as opposed to hubs. So switches replace the functions of hubs nowadays. So switches keeps a table of all the MAC addresses for devices connected to it. When a frame is received, the switch searches its MAC address table for the destination MAC address and send the frame only to the device with that address. So switches usually don't do flooding. Hubs does. So when a switch receive a frame, instead of sending it everywhere like the hub does, it just searches the MAC address table for the destination MAC address and only send it that frame to that particular device that associated with that address. If the destination MAC address is not available, then the switch sends the frames out all ports except the receiving ports. So the only time the flooding happens in switches if the MAC address is not in that table. But once that MAC address is learned, after that flooding happens, the switch again revert back to doing a specific destination-based forwarding of those frames and packets. So keep that in mind. So that's what makes switches so efficient, hence reducing the network congestion as opposed to a hub. So let's look at switches a little bit in depth. There are two types of switches, one called managed and the other one is unmanaged. Unmanaged switches, as it described in English language, it is unmanaged and require no setup or configuration and doesn't have many advanced features that comes with managed switches. Managed switches, which are most of the switches that you would get from places like Cisco switches, has firmware that can be configured to monitor and manage network traffic. Those managed switches can be used to subnet a large LAN into smaller subnet called virtual LANs or VLANs, which can reduce network traffic and congestion and also can break down some broadcast messages. In 2022, most switches used in business and enterprise environments are managed switches, such as the Cisco Catalyst line. When it comes to in home use, some of the home use switches also are managed switches, one way or the another. So they maybe have highly manageable switches or a little bit of low-level manageable switches. Reasons to add switches to your network include to add network connections, like additional network connections, to regenerate the network signal, or to manage network traffic by breaking down those broadcast domains and different domains by adding multiple switches within your local area network. Ethernet cables and connectors. Ethernet standards include copper media standards that are twisted pair and coaxial, and can support 10 megabyte per second Ethernet in the coaxial method. This was first invented in 1970s, and 100 megabyte per second, also known as fast Ethernet, uses copper cabling rated for Cat5 or higher, while the 1000 megabyte per second Ethernet, also known as gigabit Ethernet, can support up to obviously 1000 megabyte per second, and becoming more popular choice for local area network technologies in 2022, and uses same cabling and connections as the fast Ethernet. So it is easy to retrofit as long as your NIC network interfaces support 100 megabyte per second. You can retrofit the 500 megabyte per second Ethernet cable, because the cables are very similar, configurations are very similar, crimping, and you don't need to have specialized training or anything else, specialized equipment to do it, and it's very simple to set up, going from 100 megabyte per to 1000 megabyte per second connections. 10 gigabyte network connections typically uses fiber optic cables, so that support much higher bandwidth and throughput, which is a good choice for network backbones. Those are basically channels whereby the local networks can connect to a wide area network or each other. So the backbone networks could be, you have a campus wide network where different campus buildings are connected together. Those are maybe in a ring topology or whatever the topology you use, but that backbone network can be optimized by using fiber optic cables. So that could be the gigabit Ethernet. Sorry, 10 gigabit Ethernet, not gigabit Ethernet. Sorry about that. They should read 10 gigabit Ethernet. Gigabit Ethernet is 1000. It's a 10 gigabit Ethernet. So let's look at twisted pair. Twisted pair cables are the most popular cabling for local area networks or LANs, whether they are home users or whether they are business enterprise users. We use Cat5e, Cat6 cables a lot in the industry. And those are twisted pair cables and uses pairs of wires twisted together to reduce crosstalk. So basically how we reduce the interference that degrades the signal or wire, which is called the crosstalk, is by twisting pairs of wires, right? So that's why it's called twisted pair cables. The common in two varieties that includes the unshielded twisted pair or UDP or shielded twisted pair or STP. Those are two types of varieties associated with twisted pair cabling. UTP cable is least expensive and most commonly used because that shielding do cost add to the cost of that manufacturing of that cable. STP cables uses a covering or shield around each pair of wires to protect it from electromagnetic interference, and therefore it costs more than the TCP, right? Because that the manufacturing process have a higher cost associated with it. And here is a table of twisted pair category, cable system, frequency associated with it, and whether it's shielded or not, and some associated information with it. And for your A+ certification exam, yes, I would actually learn about these items or memorize this table for your exams and quizzes, because this is a very important concept in network systems that you need to understand even when you are trying to troubleshoot systems, right? So Cat5e is the 1000 base T, and it's support the frequency up to 100 megahertz. And it could be either shielded or unshielded, and has two wire pair, and is seldom used today because we have an enhanced version of Cat5e called Cat5 called Cat5e, which stands for Cat5e enhanced, because that is an improvement over the Cat5 that has same 1000T base, but now can also support gigabit Ethernet, and frequency can go all the way up to 350 megahertz, and it can be either shielded or unshielded, and has 4 twisted pairs and a heavy duty stealth sheath to help reduce crosstalk. So this one, Cat5e, which improve or enhance the Cat5 technology and hence allow higher throughput or bandwidth. Cat6 improve on top of Cat5 twisted pair categories by allowing not only 1000 base T gigabit Ethernet, but also 10 gig Ethernet at a shorter distances. So as opposed to fiber optic, remember I mentioned fiber optic is the best 10 gig Ethernet connection on the previous slide, but for very short distances, Cat6 cables can be used to connect a 10 gig connections as well. That support up to 250 megahertz frequency, and again it can be shielded or unshielded, and again it provide further less reduction in crosstalk because it has a plastic core that keeps the twisted pair separated. So if you look at a Cat6 cable, it has a plastic core separating each twisted pair cable. So two twisted pair cables each are separated now with the plastic core in the center. So there are two types or two versions of twisted pair cables. They are the straight through cable and the crossover cable. The straight through cable used to connect a computer to a switch or other network device. So these are typically known as patch panel cable or patch cables. The crossover cables used to connect two like devices such as hub to hub or to a PC, and transmit and receive lines are reversed, and therefore that's the term crossover come from. In most cases, we would be using straight through cables for reason for being that is the most widely connected devices, so unlike devices, right? So that's why we use straight through cables a lot in the industry. But what you need to understand is that the straight through cables are used to connect things like computer to a switch or to a network device, while the crossover cables are used to connect like devices such as hub to a hub or a PC to a PC. One thing I would like to highlight is that modern day switches and network interface cards on devices such as computers can auto configure itself based on the cable type. So you can actually use a straight through cable to connect a PC to a PC if there is a need for it, and the network interface cards are smart enough that it will automatically switch the way that it communicates. So that is another reason why patch cables or straight through cables are very commonly used in the industry as opposed to crossover cables. But for your exams and quizzes for A+ certification program, you need to understand why we have these two types. So straight through cables for unlike devices and the crossover cables for like devices. Even though modern day equipment can handle either cable and can switch the way how they communicate based on the cable that each get connected. The RJ45 connector has 8 pins. However, the base 10 base T and 100 base T Ethernet only use 4 of those 8 pins. The other 4 doesn't actually get used. The gigabit Ethernet, however, use all the 8 pins available on the RJ45 connector. Twisted pair cabling is color coded in 4 pairs, where solid wire and a striped wire are in a pair. So we have a solid color wire and a striped colored wire. For example, you have solid orange and a stripe orange, solid green, a stripe green, for example. So it will have like a solid wire and a stripe wire of the same color, that is twisted in together. There are 2 standards for wiring. Those include the T568A and T568B, which I will quickly cover like a high-level overview in the next few slides. So unshielded twisted pair cables and an RJ45 connector used for local wired networks are shown here. So these are unshielded pairs, and you can see that the Cat6 cable have that plastic core in the center, separating each twisted pair, hence increasing the reliability and reducing the crosstalk between these cables, these wires, while the typical Cat5e cables don't have that kind of a solid core in the center. And the RJ45 connector is basically look like this. And you can either create these connectors by yourself by using a crimping tool, or you can buy those patch cables where it is already crimped for you. So as I mentioned, there are 2 standards. That's T568A and T568B. So those are the crimping standards for the jacks. So otherwise, other way of saying it is that those are the standards that we use for the ends of those twisted pair cables. And how the difference between how these are different from each other is the way how these pairs are connected. So if you look at the T568B, you have orange, stripe orange, solid orange, stripe green, solid blue, stripe blue, etc., etc., and the same on both ends. And in the T56B version, T56B wiring version will have solid stripe green, solid green, stripe orange, solid blue, so on and so forth. So the color order has changed. So this is T56AA, this is T56B. So I just said it in reverse, but it's what you need to understand here is that the color order has been changed. For your A+ certification program, you need to know these color orders, and it will show up on your exam. So it will tell you like, what is the T56B color order? You should be able to tell me that color order. What is a T56 T568A color order? You should be able to tell me what is the T568 color order. So during an exam, you should be able to tell me that. And how you count the pin is you take this jack and the clip side, you're gonna face it outward. So you're gonna hold the jack towards you with the clip facing outward, and you're gonna count from left to right. 1, 2, 3, 4. That's how you count the pin numbers. So the pin, the color that which the pin number gonna take, each pin number gonna take different from T56B from T56A. So okay, to T568A. So keep that in mind. So you should know the difference between T568A and T568B for your exams. For a crossover cable between like devices, like two PCs or two switches, one is T56A and the other gonna be T56B. That way you get the crossover connection that you need. But again, I want to highlight something. Things like Cisco switches in modern day, you can use a straight through cable, a patch cable to connect two switches, and it'll automatically reconfigure the way that it communicates, and you'll be fine connecting those two switches, no problem. But this is something that you need to know for your A+ certification exams, because there are situations you must use a crossover cable to connect between like devices. So keep that in mind. Again, please remember the color order. You can post this screen and memorize these color orders for T568B and T568A standards, because this will show up on your exam. One more thing I'd like to point out is that the most commonly used standard right now in 2022 is the T568B. But it doesn't mean that there is any difference between T568B and T568A. You just need to make sure whichever the wire that you use, either end, both ends done the same way. If you want to have a straight through patch cable and done in a reverse way, one T568A and the other side T568B, if you want a crossover cable. So that's the key important thing you should get out of this slide. On the next slide, I'm going to just quickly go over what these wires means and why we have it. So if you look at the pin configuration, remember the pin is count from left to right while the clip is facing outward. So why this matter is that the first pin is transmit positive. So that's the positive wire for transmission, and it's white, green and white, orange. On the white, green on the T56A, T568A, and the white, orange on the T568B. So then the second one is transmit minus, and next one is receiver plus. And these two wires are only used in gigabit Ethernet, and then we have the receiver negative, and then we have the other two wires only used in gigabit Ethernet. So you don't really need to know this in detail, but you should know the differences in how these are configured with respect to pin number and the T568A and T568B wiring standards, how they differ from each other. So that's something you should know. Tools for twisted pair. So as a IT technician, you should know basic tools that you can use for twisted pair wiring. Those include the cable testers, tone probe kits, crimpers, punch down tools. So the cable tested could be something like these ones. These are handheld cable testers. Fluke is a major company, major manufacturer of cable testing equipment. So these guys have these devices where you can plug in your Cat5 or Cat5e or Cat6 cable, and it can test for proper crimping and correct connectivity. So those could be cable tested. Tone probe kits are also type of a cable tester, where you plug it in one side cable to the the system, and you use a tone probe to locate the different wires and cables. So those are called tone probe kits. This is also a type of way to test your cable connectivity as well as where the cables are going. And then the crimping tool that I mentioned previously a little bit, that looks like this. And this tool allows you to put your this type of end, RJ45 end, and then using that RJ45 stone, not the stone, the jack connector, and you can crimp it so that you can have different lengths of cable, like different variations of length of cables based on your needs. So you can buy big drums of Cat5 or Cat5e or Cat6 cables, and then you can make your own cables using these type of crimping tools. And this is a punch down tool. What the punch down tool gonna do is basically, when you have a stone, which is where the jack, the actual jack itself, the jack connection, which is the female end of the things. This is the male end of the things, this one, and this is for female end of the things. You basically put the wires in, and you use this punch down tool to make sure that those wires goes into the right configuration. And again, I'm not gonna go into detail on these stone and configuration and stuff like that in terms of how the stone is wired, because this is the let's go back again. So this is the jack. So the stone is the one that actually take this jack in terms of how that is wired. You can actually simply read most of the stone's top label, and it will give you a type and the B type. So it will give you the option for T568A and T568B wiring standards. You just have to follow that order, and you just punch it down using a tool like this. So keep that in mind. So next we're going to look at fiber optic. Fiber optic cables transmit signals as pulses of light over glass or plastic strands inside protective tubing. So fiber optic cables can be either made out of glass or plastic strands. Glass ones are the most common ones, however, the glass fibers. And they're come in two types, one called the single mode and the other one called the multi-mode. So the single mode cable uses a single path for light to travel through it, while the multi-mode cables uses multiple paths for the light to travel through it. Both single mode and multi-mode can be constructed as loose tube cables for outside use, as well as tight buffered cable for indoor or outdoor use. So those can be manufactured in either way. I recommend watching my previous lectures on fiber optic medium and my future lectures. When it's come to the point, I'm going to be posting some structured cabling lecture series to better understand how fiber optic cables work. But for A+ certification program, these are the basic broad overview of fiber optics that you need to learn for your exams and quizzes. And on this diagram on the bottom of your screen, we have a multi-mode fiber, and the light will travel across like that, multiple paths. And the single mode fiber, the light will travel across a single path that within that glass fiber. So those are the differences. And there are some speed differences between the single mode and multi-mode. You can simply Google search that one too. I believe you may have to know that for A+ certification program, but I don't think it is a key piece of information that you should know. For termination, you must use the correct tools. Again, just like previously for copper cables, this one have specific tools that you need to use. Fiber optic capable other intermediary devices such as switches, routers, etc. Must be used as well. So you can just use whatever the older generation switches. For example, you need to have fiber optic support, SFP connectors, for example. So most directly connected to servers, most commonly fiber optic is used for direct connections of servers and intermediary devices, but you can also direct connect to other devices as long as the end device have the correct connection port. So keep that in mind. So typically fiber optics are used for backbone infrastructures, but there are things like fiber to home, which I have discussed in my previous lecture, where you can get fiber optic cable all the way to your home, and at the demarcation point ONT, you can then use the Cat6 or Cat5 cables to run your LAN local area. But commonly the fiber optic is directly connected to things like servers or network backbone devices, so that it will have a very high bandwidth and throughput and reliability. But again, you can put a fiber optic network interface card directly onto your desktop computer too, if you desire to do so. And here are some examples of different connection endpoints you can have with the fiber optics. Just like RJ45 jacks, these are standard jacks. The most commonly ones would be the SC, ST, and LC standards, but these other standards also do exist in the industry in certain situations. And when it's come to the point tools for fiber optic, there are fiber fusion splicers, fiber fusion machines, fiber optic cutters and strippers, fiber optic cleaners, laser safety glasses, visual fault locators or inspection cameras, and tube cutters and knives. So these are all part of the toolbox that you should be using for fiber optic. The tools sometimes comes in this kind of a configuration. So this is a fiber fusion splicer and a fusion machine. You basically take two fiber strands together that are cut and then put it into this machine, and you can fuse them so that it'll be into one machine. One line. And this is another machine that we use to make the end pieces. And here is a device from Fluke that is a visual fault locator, or it is an inspection camera that you put it into the end of the fiber cable, and then you can check the continuity across that cable. Please keep in mind, when you're working with fiber optic, you have to pay a lot more attention than when you are working with copper wire cables, because there are some safety considerations associated with fiber optic cables. Those include tiny glass shards that can get into your nose, your lungs, or your eyes. And the other thing is, you should never look directly into a fiber optic cable, because if for some reason the other end is turned on and the laser signals are coming in, it can burn the back of your eye, and it cannot be repaired. So your eye would be like, it's not medically repairable. So keep that in mind, right? So be careful when you're working with fiber optic cables. Again, I will go over an extensive lecture on fiber optics when I'm going to do my structured cabling lectures in the next few months. So for now, this is all you need to know for your A+ certification. So we're going to switch gear again, and this time we're going to discuss wireless access points and bridges. A wireless access point allows wireless device connection to a LAN or multiple LANs too. And it can double as a router sometimes. Some wireless access point have built-in routing capabilities and can also be a bridge. A bridge is a device that stands between two segments of a network and manages network traffic between them. So basically, a wireless bridge would act like a device that would allow your users to connect to your wireless network and then communicate with your wireless local area network, wired local area network. So that's what the bridge does. So it's bridging the wired connection and the wireless connection. So you will have an antenna like this, and the people will be connecting to those wireless network through that antenna, and then that antenna is directly connected to this bridge is directly connected via a Cat6 cable to your local area network, and hence it's acting like a bridge. And these type of bridges also keeps a table of MAC addresses just like a switch. So you can look at wireless bridges as a type of a switch because it does contain those MAC addresses. And remember, wireless access point also can be double as a router as well. In business and enterprise environment, we usually deploy multiple access points across same and/or multiple floors to increase coverage and capacity. So in business and enterprise environment, you can get multiple wireless access points like these, and you can spread it across a single floor or multiple floors, or you could have a wireless access point like these ones, like this type of antennas, and then they can work together in tandem to create a full coverage for a large area of your building. Again, you want to learn more about wireless access points and bridges? Please refer to my previous lecture on this particular lecture series, as well as there are some lectures from CCNA program that I have done previously. Also, in the future, I will be posting some more videos on wireless access points and bridges that goes into in-depth analysis on how wireless technology works. But for now, this is all that you need to know. So factors to consider when installing a Wi-Fi access points and bridges. Those includes that most devices are PoE. PoE stands for Power over Ethernet, which I will discuss in the next few slides. Just for now, just remember PoE stands for Power over Ethernet, and that allow you to put a wireless access point or a bridge in a building without the need to supply it with a separate power source. So power will be provided through the Cat6 cable or Cat5e cable directly. So you do not need to have a separate power source. That's what the Power over Ethernet going to do. But however, one thing you need to consider in this situation is the distance from the PoE switch or injector matters. What I mean by that is that depending on the manufacturer, the device model, and the type, whether it support Cat5e cables or whether it can support all the way to Cat6 cable, and the type of cable you use, whether you use the Cat5e cable or Cat6 cable, the distance in which the Power over Ethernet works may varies. So slightly, not a lot, but slightly. So I believe the Cat5e can support up to 100 meters of length, but then your Power over Ethernet switch or the injector should also be able to inject for that distance, because otherwise it's not going to work, right? Keep that in mind. So one way you would know this is a problem, the distance is a problem, is maybe your device won't power on with that big distance, but it does power on with a shorter distance. Another way you would know is that it works at some times, but when the congestion become increase as the time goes by, with the congestion increasing, a lot of people are accessing the Wi-Fi network, the bridge or the access point goes down. That is another indication that maybe not receiving sufficient enough of power. So keep that in mind. Physical placement and coverage. So whenever you have multiple access points, you can do slight overlapping of the coverage so that there is no dead spots. Signal interference and wireless channel selection. Again, I'm not going into depth of how you can select different wireless signal channels, but certain channels may give you more interference than other channels. And in terms of signal interference, if you place a wireless access point in the kitchen area where there is a 2.4 gigahertz wireless band is being used, that may have an interference with your microwave. So things like that. Maybe change the location of the microwave or change the location of the access point. Again, I will do a separate lecture on wireless that will go much more comprehensive in depth. For now, that's what you need to understand. Capacity, homes, small businesses, and football stadiums are not the same. Homes have low capacity typically. Maybe one person live in the apartment, or maybe 3 or 4 people live in the house. Or maybe 10 people live in a house. That's pretty much it. That's a home. Typical home in Canada is maybe 1 to 5 people maximum, typically, right? Not always, but typically. But when it's come to small businesses, you're going to have hundreds of people maybe connecting to that Wi-Fi network. So you need to think about capacity. So you might have coverage of the Wi-Fi network, but your access point that you purchase, the bridge that you purchase, may not be capable of handling 100 connections at the same time. So keep that in mind. Home use access points may not be a good idea to be installed in a small business and even enterprise environment. Now, if you scale one more step up, such as a football stadium, where you are providing free Wi-Fi access to guests, that would require really good wireless access points that can handle hundreds of connections at a time, if not thousands of connections at a time. And you may have to install multiple wireless access points with very high strength signals in order to grab all those communications properly and lock onto those. So keep that in mind. Again, this is not in depth, this is a broad overview. Just keep those things in mind as an A+ certified technician. Also, you need to understand the features that some of those access points and bridges support. Those includes the enterprise features such as the direct AAA server support. What's a AAA server support? AAA stand for authentication, authorization, etc. And then what is that? I will describe that in a later video. I have already described that in my previous lectures. What is a AAA server? But some of the what you need to understand is some of the access points and bridges do support direct AAA connections. So those are considered as enterprise features, or token authentications, things like that. Multi-powered network connection support. So some of them have a way that you can plug in access points in a type of like a series. So you don't have to pull cables everywhere. So you can use one Cat6 cable going into one access point, and then you have another out from that access point itself. Then you can plug in the next access point, and next is like a daisy chaining. So there are some enterprise Cisco devices you can do that. Weatherproof outdoor devices, that's another thing you should think about, especially in Canada. We have temperatures goes all the way up to 35 degrees Celsius positive during summer to negative 40-45 degrees Celsius. So we go from really hot summers to really cold freezing winters. So if you are putting wireless access points and bridges outside, you need to make sure either you have proper housing or cases for that, or you have some type of a weatherproof specifically built purpose built access points and bridges that works in the Canadian weather conditions. And always, as with any computer, networking or electronic device, please follow the manufacturer's documentation when setting up all of these devices, because each manufacturer have different way of setting up. The way that the Cisco set up wireless access point is different from Unify, how they set up their access points. So I can't go over every single one of those access point setups. So in my previous lecture, what I have done is I cover some basic Wi-Fi setup process, which also can be applied to how we set up access points and bridges and other devices as well. So those are just general methodologies. As a technically inclined person who is interested in A+ certification and working as an IT technician, you always should be able to read those manufacturers' documentation and understand how those specific little details, how they are different from manufacturer works, and then you can use them to set up these network systems. Wireless antennas. So Wi-Fi supported routers and switches usually have omnidirectional antennas. So those omnidirectional antennas look like these. So these are omnidirectional antennas on a home use Wi-Fi router, and the antennas on some of the access points that I have discussed right here, like these type of antennas inside these here, they are typically omnidirectional. These are typically omnidirectional antennas inside in those devices. So those are the common type of antennas we have. But sometimes using just an AP or a bridge or a Wi-Fi enabled router is not suitable in all cases, right? So in that time, we may have to use the site-to-site Wi-Fi networks that require specialized antennas that can support long distance communications. And those antennas provide high bandwidth and speeds and must be installed according to the manufacturer's guidelines, local laws, and ISP customer agreements. So those antennas are typically directional antennas because they allow site-to-site Wi-Fi networks, and they look like these. They typically go outdoors, and they have either a dish-shaped antenna, something like this one, or they would have a square antenna, something like this. And sometimes they're like a square drum as well, and so it's either drum antenna or a dish antennas. And what they are going to do, actually, they allow you to connect site to site Wi-Fi networks together. But keep in mind, you need to follow the manufacturer guidelines plus your local laws and ISP customer agreements. For example, I have Show Cable Home High-Speed Internet Connection, which is a Canadian internet service provider. And my agreement with Show Cable is I'm not allowed to actually share my internet with another house. So I can just put up an antenna like this and share my internet using this type of site-to-site Wi-Fi connection with another house, because it's illegal. It is against the policy between ISP customer agreement. Local laws come into play as well, because these antenna goes outside of your building and typically stick out from your top floor rooftop or on the side of your buildings. You may need certain licenses to put this thing out due to local regulations on how these should be installed. So in terms of like typically in most countries, you can use any of these antennas just by going to the store and purchasing it. So you don't need to buy a license to operate these antennas, but you may need a license to install those antennas outside. So keep that in mind when you're using a directional type of antennas, such as the site-to-site Wi-Fi antennas, such as these ones. These are typically directional. That's another thing, another difference, that the Wi-Fi antennas here are omnidirectional, while the Wi-Fi antennas here are directional. So it's directing in one direction. So keep that in mind. Again, I will go over this in detail in a separate video. For now, that's all you need to know. Wi-Fi mesh networking kits. So this is a popular thing that's becoming more and more popular in 2022. How mesh networking works is basically that each device is connected to each other. So all stations are interconnected. So these mesh devices, such as these devices, they are called stations. So stations are basically key components of a mesh topology. This is what a mesh topology look like. And then what happens is, so imagine this point is one of these or one of these. It doesn't really matter. And what this mesh point gonna do, which is the mesh station gonna do, it's gonna connect to every other available mesh station in the system. So for example, this is connected to this one, this is connected to this one, this is connected to this one, this is connected to this one. So now this particular one point, this one station or device in this mesh network have connection to 1, 2, 3, 4, the other 4 devices. Same here, this point have connection to the other 4, 1, 2, 3, 4. So it provides redundancy for a network, but can be costly due to a high number of connections and total length of use cables. Like for example, you may have to put cables to this one and cable to this one and cable to this one. So unlike a Wi-Fi network, even though they are bouncing off against each other wirelessly, but these things probably need to get sometimes connections directly, not just power, but not always, because sometimes you can give a network connection to one of these and the other one's just going to be just power only, and it will just bounce off wireless signal from this. And they are used both in home environments as well as in some enterprise environments as well. So while the mesh networking kits are becoming very popular in home environment because it's very easy to install, like as I mentioned, in home environment kits are sometimes you just plug it in one of them to wired network, the others are just wireless. You only need power. You can put it anywhere in the house and it'll bounce off each other, right? And you can provide coverage for areas where it is next to impossible or harder to get a wireless signal or to install a wired cable and LAN connection. So this gives you the flexibility to get network connections, LAN connections into areas where it is otherwise would be impossible or harder to reach. And in some popular deployments of enterprise environments include large buildings where they have large campuses or offices that require this type of mesh network, so that it will have better connectivity and redundancy built into it. And keep in mind, there are also 2 types of mesh network, one called the partial mesh and full mesh. full mesh happen, you have the internet connection comes into your house. So you have a demarcation point, let's say your modem in this case, or ONT if it is fiber. And then right behind it, you create an entire mesh network. So your whole house or whole building is on a mesh. That's called a full mesh. A partial mesh is that you have network connections, which is like a traditional connections going through a router and a switch. And then one of the cables or couple of cables out of that switch or router is now being used to create a mesh network. So that type of partial network is the most common type of mesh network currently in use for the obvious reasons, right? Because it's a mix of full mesh and the traditional LAN network connectivity. And the mesh topology provides, again, this is the key thing that you need to understand for your exams and quizzes. The why mesh topology is getting popular because it provides redundancy for a network but can be costly due to the high number of connections and total length of cables used. As a result, while it is providing the redundancy, it may not be getting as popular as it should have been if the cost associated with those running cables are cheaper, right? So that keep in mind. So if one station fail, then how the redundancy is provided on this situation is that if one station fails, the network can continue to operate by using the other nodes, or also known as stations, which are sometimes called nodes of the mesh networks to communicate. So if this station fails, if this thing goes out and this guy still can reach this guy, it doesn't have to go through here, it can go through here, or it can go straight to here. So if one station fails in mesh network, it will still find another way to communicate that. So each node in each station can be a router that creates and modified dynamically to transfer data in the most rational way. So that will use the dynamic routing protocols in order for mesh network to work. So I'm going to repeat that. I know it's a little bit confusing. So each node, in other words, each of these stations kind of acting like a router. It dynamically transfer data in the rational way, allowing each of these nodes to communicate against each other even when there is a failure of one of those connections. So if this thing fail and this thing fail, this guy still can connect to here through this line or this line, etc., etc. So mesh networking is a really good option for redundancy, and it is easy to deploy. Next, we're going to talk about Powerline Ethernet. So Powerline Ethernet is also known as Powerline networking and sometimes also called Ethernet over power. It can provide gigabit speeds and use existing electrical wiring of a building to send network data signals using unused frequencies. So this is another way that you can build your local area network. So it requires the use of at least 2 Powerline network adapters. Like for in this example, we have a network adapter here and a network adapter here. These are both are Powerline network adapters. And on the modem router switch side, and the other one will be on the distance location. So one of the network adapters for power over Ethernet, Ethernet over power, not to be confused with that. Ethernet over power is to, you have a specific Powerline network adapter that is connected to your router or the modem. And then the other end of that will have a specific device for Powerline networking, Powerline network adapter that will allow you to connect devices in that remote location or a distance location, right? It can provide both wired LAN and Wi-Fi capabilities. So you can use a Powerline Ethernet adapter on the one floor, and another floor, another area. You can have another Powerline Ethernet adapter, and you may have a network RJ45 jack out connections as well as Wi-Fi connections. So it doesn't necessarily have to be a Wi-Fi connected one. Okay, so you can even connect to your router or a switch using Wi-Fi or wired, and you can connect to the devices on the other end of the line. Either by Wi-Fi or wire as well, even though in here it's only showing Wi-Fi. It is not recommended for business and enterprise environments because there are some security issues that you need to take care of, and some electrical interference and other issues might come in. And the flexibility and the configurability and the features that require in the enterprise and business environment is typically not found in Powerline Ethernet. So the key factors to consider when you are installing Powerline Ethernet includes the electrical wiring in the building is too old. If the wiring is too old, or the distance between the adapters is too large, that will degrade your signal. So if you have a really old house and your wiring is really old, I would not recommend installing Powerline Ethernet even for home, because that will either have network connectivity issues once in a while, or it could create problems when you're trying to download large files or try to get high throughput out of that. It's not going to work very well. Increased number of Powerline adapters also result in increased network congestion. So if you put a whole bunch of Powerline adapters in one single electrical circuit, that would create a very high congestion situation where network will bog down. Distance between the adapter impact the signal quality as well. So the larger the distance between the two adapters, like in this case, if the distance between this one and this one getting increased, like if you put in the 4th floor, for example, that will significantly have an impact on the quality of your data signal. Adapters must be plugged directly to the wall. That is a really important thing as well. So please do not plug your adapters across other electrical or electronic components. So these type of adapters, these Powerline adapters like these ones, it needs to be directly plugged into your city's power connection. So the reason for that is that if you have a UPS, or if you have electrical conditioners, or other devices, surge protectors, for example, surge protectors, UPS, electrical conditioners, all of these things can look at the data signal and consider that as, identify that as a electrical noise or unwanted noise and suppress it or cancel it out. As a result, your Powerline Ethernet not going to work. So you have to make sure that the adapters are directly connected to the wall. Otherwise, you will encounter problem as a result of your UPS or power conditioning devices or surge suppressors, eliminating the data signal. Because we are using the electrical wiring to send the data signal across it, right? So that's why that could happen. And you need to secure this type of Powerline Ethernet connection just like a Wi-Fi network, especially when you use it in an apartment buildings. So if you are using Powerline Ethernet in an apartment building, an apartment complex, it is more than important to just plug it in and do the basics configuration, but it is very, very important that you actually secure that just like a Wi-Fi network according to manufacturer specifications. So you need to just look at how to secure depending on whether you bought a Netgear or a D-Link, etc., Powerline Ethernet adapters, and then you need to secure it with a strong password and encryption. Otherwise, what's going to happen is it will be much easier for someone to grab that signal or data. Keep in mind, even across a breaker panel, anyone who is sharing the same electrical system may be able to access your network. So there is a security concern, very high security concern with the Powerline Ethernet. That's another reason why I don't recommend for use in the enterprise and business environment. Even if you have a breaker panel separating any other buildings, someone who is sharing the same electrical system may be able to access your data if it is not properly secured. Please test different combinations of electrical outlets when installing adapters for optimization as well, because you may not get the best signal strength by plugging in a Powerline adapter to the nearest power outlet to your computer or whatever the device you're trying to get the network connection. So in that case, you may want to plug it in around different circuits or different outlets in your room or in the location in order to get the best optimized condition for data transmission. And also try to avoid high power draw devices on the same electrical circuit. So what that means is basically if you plug these Powerline Ethernet adapters to a same circuit as, let's say, a device such as a microwave oven or a very large oven, what's that going to do? It's going to suddenly draw high powered, right? Whenever it's in use, that would have a result in the quality of this data signal that can be received on the other line of the power line adapter. So keep that in mind. So how the power line adapters work is basically your AC current goes like this, alternative current, and you have you have a lot of space in the frequency where you can send some kind of a pulsating signal like this one, and that frequency is being utilized by the power line Ethernet connections. So those are typically 2.4 gigahertz, but there are other gigahertz variations too in the market. Basically, as long as it is not cancelling out the AC signal, alternative current signal, or not interfering with that, you can use the frequency space available within that electrical wire to communicate. So that's how the power line Ethernet work. Power over Ethernet, or PoE. So please don't get confused with the Ethernet over power and power over Ethernet. Power over Ethernet is PoE. Ethernet over power is also known as Powerline Ethernet, which we have discussed in our previous slides. And again, on those previous slides, even I got confused a little bit because they are very same words, but the way that they are put together describe different things, right? So power over Ethernet is PoE. Ethernet over power is using power line, power circuits to deliver internet connectivity. Power over Ethernet, however, is a feature offered on some network adapters to allow power to be transmitted over Ethernet cable. So as opposed to power line Ethernet, which we are using electrical circuit to transmit data, in power over Ethernet, or PoE, we are transferring electrical current through data cables. So it's opposite. So they are used to place a device in a position in a building where you don't have a electrical outlet. So if your switch doesn't offer power over Ethernet, you can add it using PoE injectors. When setting up a device to receive power by power over Ethernet, make sure the device sending the power, the splitter, and the device receiving the power are all compatible. Modern day power over Ethernet devices can auto configure and auto shut off or auto put into safety features if it receive too much power. But so in the older devices, you have to make sure if it is for like a 5 watt rated device and you send 15 watts, it's going to burn out. So you have to be careful with that. But in newer devices, it has the way of detecting each other and adjusting the power accordingly. And also, sometimes some power over Ethernet PoE devices are not compatible against each other, but not always. Like I use a TP-Link injector with a D-Link camera, that's no problem. But sometimes it doesn't work always that way. So keep that in mind. Not all power over Ethernet devices are created equal. So check manufacturer's documentation. Like any other equipment that we have discussed even previously, not all manufacturers and all devices are created equal. Some of those injectors and switches can provide a lot of power. Some of those injectors and switches cannot provide a lot of powers, and there are some limitations and etc. And refer that to with the manufacturer's documentation. And this type of power over Ethernet is commonly used in network cameras, security devices, access points, because this way you can put an access point anywhere in the building by just pulling a Cat6 cable, and you don't need to worry about providing power to that device. You basically providing power through the same network data cable using a power over Ethernet system, right? So that's why these are commonly used with network cameras, security devices, and access point. And on the bottom of your screen, you see an injector. This is an example of a TP-Link injector where you provide the power via your wall outlet or UPS across that, and then this is going to get connected to a PoE device, like a network device, let's say an access point right here, and then you connect the other end of this. There is another switch, other RJ45 outlet here on the back side of this, and that get connected to a network switch, and then the network switch can be be powered on through the injector as well. So there are multiple way of doing this as well. Like in this one, I believe this one just a power here coming in, and then it's injecting both the switch and the access point, and they're doing the data and all together. But some do it in a way that where you have the power and the network connection goes in with another in a different configuration. But at the end of the day, this is the fundamental concept that you need to understand. So you have an injector because the switch doesn't support power over Ethernet, and then that injector is providing the power to the access point and taking that data across this network switch across to the access point using the same cable. In this situation where PoE enables switch, you don't need to do that. You just basically plug it into one of those ports that support PoE, the access point, and then access point get powered on by that cable and receiving the data at the same time. So again, don't get confused between the power over Ethernet PoE and Ethernet over power, which is the Powerline Ethernet. Those are two different things, and that will show up on your exam, and that is important that you understand that. Network servers. So some servers are standalone devices, but often multiple network services are provided by a single computer server, right? So basically what that means is you can have a HTTP server, mail server, you can have print server, all in a Windows server or a Linux server on a one single box. Servers might be embedded in other devices as well. So it is possible that you can have certain server features embedded in another device. An example would be a DSCP servers are oftentimes embedded in an access point or sometimes on a router or something like that as another device. But you can also install the DSCP server on a physical desktop servers as well, or rack mountable servers as well. On large networks, network services are often provided by multiple servers so that if one goes out, then the others can fill in the gap. So that is called the redundancy, building the redundancy, right? Client server resources used on networks and internet includes the web server, mail servers, file servers, print servers, DSCP servers, DNS servers, proxy servers, authentication or AAA servers, and syslog servers, etc., etc. So these are some of the most commonly used servers, and most of these servers are associated with small businesses and enterprise environment, except maybe the DSCP server and maybe the file servers, because those are even very commonly used in home environment as well. Like your home router, it has a DSCP server built into it if you automatically get in your IP addresses assigned, or if you have a NAS drive, a network attached storage drive, which I'm going to talk about next slide, that would be acting like a file server. So keep that in mind. Network attached storage. Network attached storage, also known as NAS, are devices that can be used to serve up files and to stream media files and movies to client computers. So it allows you to put all your files and documentation and media files in a one central location on your LAN. Both home and enterprise environments use NAS. They are very cost effective as opposed to getting a full-blown server. You can simply get a network attached storage unit if you guys just want to share files among your family members or your small business environments, right? For example, and they are very easy to set up and sometimes even plug and play. PNP stands for plug and play. That's a term used by the industry for devices that are basically you plug it in and do very few little configurations and it automatically start working with your device. Like in this one, for example, it even has a screen showing what IP address this device has been received. So you might not even have to access anything here if it is already built in. Some of these devices also have buttons where if you put a necessary number of hard drives, you press a button, say RAID 5 on the back of the device, and it automatically build a RAID 5 configuration and give you a drive. You just have to map those drives onto your end devices or end users' computers in order for it to access it. That's all. And features and hardware you need to consider when customizing a NAS device include the processor with moderate power. This is something to think about, because unless there is a need for a high power use processors on your NAS device, it is not recommended to buy a NAS device with a high power use processor, because then these are going to be running 24/7, 365 days per year. As a result, the home users may have a high electrical usage if you're going to use a really high powered enterprise grade NAS devices. There are enterprise level NAS devices that are rack mountable and comes with lots of features where it allows like hundreds of even thousands of people to access the NAS drive at the same time. And those have very high power processors that are not needed for home environment. So when you are configuring these NAS devices, you need to think about your end user, your client. Is it for home use? Is it an enterprise use? If it is a home use, you don't need a very high powered processor on this type of NAS. And it's conserve power and it conserve energy as well. Type of RAID array that can support. Some support RAID 0 all the way through 5. Some support RAID 5, 6 and more as well. So think about that. Appropriately sized chassis. So you need to think about the size and the dimension and where you're going to place it. Gigabit network interface card. In 2022, if you don't have a gigabit network interface card, at least one out with the gigabit interface card, I would not buy that NAS. Most NAS devices in 2022, even home use devices, have multiple gigabit Ethernet cards, typically 2 at least minimum, and those allow high bandwidth and throughput. Media streaming capabilities may be differ from based on different firmwares that are used by different manufacturers. So depending on the manufacturer, the media streaming capabilities may slightly differ. Some may be better than the other. And also remote access and security associated with those remote access. Again, not all firmware and all manufacturers support all versions of security and types of remote access. So that is something you need to take into consideration when you're purchasing a NAS. NGFW and UTM. NGFW stands for Next Generation Firewall, which combines firewall functions with antivirus, anti-malware functions, and possibly offer other functions as well, such as deep packet sniffing. I am not going to discuss in detail in this class how exactly those work and how you can configure firewalls such as Palo Alto, because I'm doing a completely separate lecture series on advanced firewall configurations that will give you a much better comprehensive understanding about NGFW. For your A+ certification exam, you don't even need to know the configurations, but you need to know these things do exist on the exam. So you need to know they exist, but you don't need to know how they exactly work. So an NGFW, not NGFW, sorry about that. So NGFW device, also known as the next generation firewall device, can offer comprehensive unified threat management, also known as UTM services. A UTM appliance, which is a security appliance, it can be a network appliance or an internet appliance, which is basically a device. It's a physical device go between your LAN and your internet. So basically it stands between the internet and private network, to protect the private network from the internet, allow you to do all of these UTM configurations. So UTM, those kind of UTM configurations includes the firewall, antivirus, anti-malware software, identity-based access control list, also known as ACLs, intrusion detection and intrusion prevention systems, endpoint management servers, and VPN. Again, I'm not going to go into detail on those things. Like I'm not even going to explain what's the difference between IDS and IPS, but know that those things exist in this lecture. So in this lecture, I'm not going to go any more further than this, other than to say the next generation firewall, also known as the NGFWs, allow us to use the unified threat management services and those are typically come in as a network appliance that sit between the outside network and the inside LAN network. So it basically going to break that into, they separate those two, and then they provide the firewall, antivirus, anti-malware, identity based access control or ACLs, IDS, IPS, etc., etc. And also sometimes they can also provide VPN support as well. So that's all you need to know for now. And again, are you interested in network engineering? So in this A+ based lesson, we went over a broad overview of network systems. But however, you can get more in-depth knowledge with my previous lectures that I have posted on my YouTube channel, which include hours and hours worth of CCNA lecture series. Lecture series CCNA 1, lecture series CCNA 2, and series CCNA 3. Those includes hundreds of bits of pieces of information that will enhance your understanding about network engineering. So if you are interested in that, which is more than what you need to know for your A+ certification exam at this point, you can go ahead and watch my YouTube videos that have already been posted. And I will leave the links for those playlists in the description of this video, so you can click on them and watch them. And that is the end of this lecture. If you like these kind of lectures, please thumbs up this video and subscribe to my channel. Until next time, good luck with your exams and have a nice day.